You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. We've just waded through a mountain of intelligence on the latest digital threats, and, well, to say the landscape is a minefield feels like a bit of an understatement.
It really does. I mean, the level of operational awareness you need right now is just through the roof. The sophistication we're seeing from platform flaws to AI-driven social engineering it's just staggering.
Exactly. So our mission here is to cut through all that noise, all the jargon. We've sifted through these threat reports, everything from, leaked developer secrets to AI agents hacking crypto.
Yeah.
And we're pulling out the 3 most critical lessons you need to know.
Right. This is your guide to where the real risk is today, and we should probably start with a number that should be on a poster in every single engineering department, 17,430.
Let's just jump right into that number. We're talking about a critical, massive exposure right in the middle of the development lifecycle.
Mm-hmm.
That number, 17,430, is the count of active, verified secrets found exposed across 5.6 million public repositories on GitLab Cloud.
It's just a staggering figure. It came from one researcher who decided to scan the public GitLab space. And just for a little bit of context, that's almost 3 times the number they found when they did a similar scan on Bitbucket.
And when we say secrets, we're not talking about old, discarded test keys. This was a treasure trove. It included over 1,500 Google Cloud Platform keys, MongoDB credentials, even OpenAI keys.
Yeah, but the real danger here isn't just the sheer number, it's the timeline.
The time.
That's the most critical part. Some of those valid, exposed secrets, they go all the way back to 2009.
Wow.
Think about that. A key written 15 years ago, probably by a developer who's long gone, is still active, still sitting out there in public. An attacker doesn't need to be clever. They just need to harvest old keys, and suddenly they have a persistent, stealthy foothold. It's a total systemic failure of credential management.
So lesson 1 is basically that our old digital garbage is creating these huge gaping holes.
Right. And it's not just your own secrets. It's the instability coming from third-party code. I mean, look at this new flaw in React 19. They're calling it React 2 Shell.
Okay, that sounds bad.
It is. It's a remote code execution vulnerability, so RCE. And because it's in something as foundational as React, the exposure isn't theoretical, it's immediate, it's widespread, and it gives attackers a known path into, well, talentless applications.
And then there's the stuff that's even sneakier, like code that just gets abandoned. We saw these reports about old Python bootstrap scripts.
Yeah, in PyTI packages, they were referencing a domain that someone just let expire.
The domain is for sale.
It's up for sale right now. And if an attacker buys it, they can instantly hijack that supply chain. Anytime that old script runs, maybe during an install, it could pull down malicious code from that newly bought domain. It's a vulnerability born purely out of neglect.
Which brings the risk right down to the developer's machine. We've seen a ton of attacks targeting their tools directly. The third wave of Glassworm malware?
Glassworm is a great example. It was hiding in 24 malicious VS Code packages. And what made it so good was its evasion. It used invisible Unicode characters for obfuscation.
Invisible characters? How does that even work?
Well, it means the malicious code is impossible to spot in a quick manual review. You look at the code, it looks fine, but the computer sees the hidden instructions, so it's stealing credentials from dozens of other extensions right when a dev is just trying out a new tool.
That is both terrifying and brilliant.
It is. So if lesson 1 is that the supply chain is just fundamentally exposed and unstable, then lesson 2 is realizing the attackers are shifting focus. They're moving from software weaknesses to human weaknesses. They're weaponizing identity.
And this is where we get into the state-aligned groups. We're talking about North Korea's Lazarus Group,
Mm-hmm.
right? Their famous Cholima division.
Yeah, and they're not just phishing anymore. Their whole strategy is shifting towards identity takeover. Researchers set up this incredible honey trap, basically, sandbox VMs disguised as developer workstations.
And they caught them.
They caught them live on camera. They recorded the Lazarus operators, documenting their entire workflow, their tactics, everything, in real time.
So what were they actually trying to do? What was the goal?
The goal was identity rental. It sounds bizarre, but that was it. They were spamming legitimate engineers on GitHub and LinkedIn, offering to rent their professional identity and their work laptop. 204/7.
Wait, rent their identity? For what?
For a cut of a salary. The operator uses that real person's identity to apply for remote jobs at Western companies, especially in crypto, finance, high-value target.
Hold on. So they bypass all the background checks by using a real person and then just use remote access software to be that person digitally.
That's the genius of it. It completely defeats remote identity vetting. They're using legitimate tools like AnyDesk to control the hired engineer's laptop. They're even using AI interview tools to help them land the job. From the company's perspective, they look like a perfectly legitimate, fully vetted remote hire.
So they're not hiding code anymore. They're hiding a malicious operator inside a legitimate person.
Exactly, and that use of legitimate remote access tools, or RATs, is a much broader trend. Ransomware groups are doing the same thing. They use AnyDesk or UltraViewer to get in, move around, get admin rights, all before they ever deploy the actual ransomware.
They want to be a quiet employee, not a noisy virus.
That's it. So they have full access before they pull the trigger. It means, if you have a remote workforce, your monitoring has to go way beyond that initial background check.
Okay, which leads us perfectly into our third big lesson. And this one really blends the high-stakes financial world, which is right in the sweet spot for our vocal technologist listeners, with the, frankly, terrifying power of modern AI.
Right. We're talking about the Web3 and AI vulnerability nexus. Let's start with the crypto exchanges. That $30 million breach at Upbit, the South Korean exchange.
Also suspected to be Lazarus, right?
Very likely, yes. The post-breach analysis found something really unsettling. It revealed a flaw that could have allowed an attacker to infer a private key just by looking at public blockchain transactions.
Okay, you have to break that down for me. How do you get the private key, the actual key to the vault, from public data?
Well, think of it like this. Certain cryptographic schemes, when you sign a transaction, they can leak tiny, almost invisible mathematical clues about the private key.
Okay.
If the system is flawed, and you make enough transactions over time, an attacker can collect all those little public clues and crunch the data until the original private key is revealed. They don't need to hack the network, they just need to analyze the public chain.
That is chilling.
Yeah.
It means the blockchain's greatest feature, that everything is public forever, becomes a weapon against you.
Now let's pair that kind of vulnerable target with what autonomous AI can do. Researchers recently tested frontier AI models against a bunch of historical smart contract exploits, and the results. They are a massive, flashing red light for the entire industry.
What happened when they pointed things like GPT 5.1 and Claude Opus 4.5 at these old exploits?
The AI agents came up with working attacks against 207 of the contracts. They simulated stealing $500 million, $550 million.
$500 million. But were they just, copying old attacks? Or did they find anything new?
That's the critical part. They absolutely found new things. The AI models discovered 2 previously undisclosed zero-day vulnerabilities.
So the AI is finding brand new bugs. That changes everything. It brings up this huge economic question, right? What happens to bug bounties and disclosure when an AI can find 0 days faster than a person?
And cheaper. That's the key finding. Autonomous exploitation is becoming economically feasible because the API costs are dropping so fast. The AI is finding, testing, and exploiting flaws faster and cheaper than an entry-level human security auditor. The window for humans to find and fix things is just shrinking rapidly.
It's an arms race, but the other side is getting infinitely faster. And speaking of clever attacks, we have to talk about some of these new evasion tactics. They're not even going after the websites anymore, are they?
No, they're going after the tools we use to understand the web. We have to talk about Hashjack. It's this new indirect prompt injection technique that targets AI browser assistants. So your Gemini, your Copilot.
So how does it work? How do you weaponize an AI assistant on a totally safe website?
It all comes down to the URL fragment. That's the little bit of text after the hash or pound sign in a URL.
Okay.
Usually the server ignores that part, but an AI browser assistant, it reads the entire URL to get context. So an attacker hides malicious commands, the prompt injection, in that hashtags section of the link.
So you click a link. The website itself is totally safe, but the AI assistant helping you reads the hidden instructions in the URL and starts doing bad things, stealing data, whatever.
Exactly. It's a genius-level abuse of the AI web interaction model. And while Microsoft and Perplexity patched this, Google, they classified it as expected behavior for Gemini, which leaves a lot of people exposed.
That pivot from attacking the app to attacking the AI interacting with the app is huge. And we have to connect this back to mobile, too. We're seeing tools that are basically the mobile version of that full remote control identity theft.
Absolutely. There's a new malware as a service called Alberiox targeting Android. Victims get a text about a discount or a prize, but the key is the VNC module it installs.
VNC. Virtual network computing, what does that mean on a phone?
It means the attacker can see a live stream of the victim's screen. They have complete real-time remote control of the device.
Wow.
It is terrifyingly intrusive. They can literally watch you type in your banking password and then just take over your session to make transfers. It's identity takeover at the OS level. It just reinforces that core idea. Attackers want to look like you, using your tools.
Which really ties all our findings together, doesn't it? The three themes are so clear. First, the systemic risk from credential exposure and a rotting supply chain. Second, that huge strategic shift toward identity theft. And third, the terrifying acceleration of financial risks because of autonomous AI.
So what does this all mean for you? Well, on the defensive side, technology is catching up. We're seeing tools like AWS Managed External Secrets, which are designed to automatically rotate secrets for third-party services. It directly addresses that longevity risk we started with.
And for investigations, there are new client-side tools like Lumen, which can analyze sensitive Windows logs locally on the machine. That means you can do deep security forensics without uploading sensitive corporate data to the cloud. It's a huge win.
But at the end of the day, we're in a world where AI agents are exploiting millions in smart contracts, while human attackers are impersonating developers in the real world. So the question we want to leave you with is this. What happens to the economics of finding bugs when an AI can discover a 0-day faster and cheaper than a junior security analyst? What should you actually be prioritizing in your organization next year?
Think about that. We will see you next time for the next set of insights into the information that matters.
Stay safe out there.
Spoken Tech for your ears.